Hey guys, for our notes today, we're going to be doing them a little different here. So I'm going to try this out and see how this works. So our notes today are on plate tectonics. So in your table of contents, what I want you to do is go in there and label this January 24th as our date. 24th, man, can't type. Plate tectonics. And whatever page number you're on. I'm not sure. We're all on different page numbers, some of us. So go in your table of contents. You want to do that first. So once you have that done, go to your next page of notes, and that's where we're going to start our plate tectonics notes. First, what we're going to cover in plate tectonics, so we're going to label this at the top, plate tectonics. First thing we're going to talk about are convergent boundaries. Actually, wait, we're going to talk about divergent boundaries. Excuse me. So we're going to draw a few pictures here, actually, for this one picture to help us understand divergent boundaries. And the word divergent, if you've ever seen the movie Divergent, so to diverge means to move away. All right, so these boundaries are not coming at each other, they're moving away from each other. So to move away, we'll put that right there. So right here, I'm going to insert a picture here, which I want you guys to draw in your notes. So give me a second, and I'll get that image up here. I got to upload it here. So let's find it here. Image. There we go. We want image. 515. Open. All right. So this is the image that we want to draw right here. So this is the ocean. These are the plates moving away right here. And as they move away, we get magma coming up. And we had seen this with the mid-ocean ridge, and we have talked about this. We had new ocean floor forming. So this is where the newest rock comes in, and the other rock, the older rock, gets pushed out to the sides. And this term for this is called seafloor spreading. All right, so seafloor spreading. So when this happens in the ocean, I'm going to put this down here. When convergent boundaries divergent boundaries occur in the water, we get seafloor spreading. Man. However, when divergent boundaries occur on land, we get what's called a rift valley. And I'll show you a video of that here in just a second. So rift valley. So for divergent boundaries, so make sure you write down what I wrote down, and we want you to draw that picture. So on your table, you'll have some markers to help you with that image. All right. So that is our first type of boundary. Going on to our second type of boundary. And let me scroll down here. Our second type of boundary are convergent boundaries. Now, convergent boundaries are just the opposite of divergent boundaries. So converge means to come together or to meet. So instead of coming apart, convergent boundaries are coming like this. And it is not button heads like this. One is actually going down and one is going over. So there's three different pictures we're going to draw for convergent boundaries because there's different types of plates. We're not really going to get into the plates. You might see it in the pictures because they're from last year, but it's more knowing what is formed when two plates converge on each other. So these three images I will want you to draw in your notes. So let's get those up here for you. All right. So let's get our first one. So our first image here is showing you an ocean plate hitting a continental plate, and what's happening here is a volcano is being formed. So in this picture here, we have an ocean plate crashing underneath a continental plate. And what happens, there's a couple terms here that I want you to write in your picture also. So one word is subduction, and all subduction means is that plate is going down. So when it goes down, that is subduction. All right. And on the other side, we have the other plate coming up, and that's called uplift. So one going down is subduction, other one's uplift. And what's formed at some of these plates are volcanoes because magma seeps up through that median of the plates and creates volcanic eruptions, volcanoes. All right. So old rock is melting when it gets pushed down, and then the other plate is pushing up, and that magma is coming up and creating a volcano. So that's our first picture we want to draw for convergent boundaries. I'm going to put the next one right underneath it here. Hopefully it lets me. At any time during this video, please pause. This will go off into the next page of the documents. So let me get this here. Alrighty. All right, so this is our next picture for convergent boundaries. Same picture. This one, we're not having any volcanoes created. In this one, you still have your subduction going down. You have your uplift coming up. And what's happening is something called folding. And with folding, mountains are formed. Okay, so in this picture, mountains are being formed. So underneath this one, we could say how mountains are formed. And one more picture for convergent. Again, pause at any time because you can pause this and look at what I'm drawing, or look at the images. So let's upload from the computer here. Image number 3. All right, so in this picture, this is how volcanic island arcs are formed. Again, I'm giving you a lot of information here, and this is how trenches are formed. So same thing, coming together, converging on each other. So one's going down, one's going up, and where the one's going down and one's going up, you kind of see there by my mouth, right there. All right, that would be considered a trench. All right, so a trench is being formed there. Okay, it says ocean to ocean, so those are ocean to ocean plates. Don't really have to worry about that in our notes. Again, some of these are older notes from last year. What you need to know is when they converge, in this instant, a trench is being formed. Okay, so how a trench is formed. All right, so what I'm going to show you right now. So if you didn't get all these notes, so remember, you could pause and go back. All right, we're not done completely with the notes, but this is a majority of them so far, these pictures. I'm going to pull up a quick YouTube video that I want you guys to see talking about divergent boundaries and convergent boundaries. So to help you get a better understanding of what we are talking about if you haven't got a better understanding over the last couple of weeks. So let's pull this up right now. And we'll let it play.
White Island, as with all of New Zealand, sits right on the rim at the junction of the Pacific and Australian plates. It's a collision area where the floor of the Pacific Ocean dives deep below the Australian plate in what is called a subduction zone. The seafloor is buckled and pulled down into deep trenches, and the friction triggers powerful earthquakes as the Pacific plate is slowly consumed. Even here, magma flows from underwater volcanoes as rocks are melted and recycled. White Island is one of a chain of volcanoes that includes the notorious Tarawera.
That was quite a bumpy flight.
So that part of that video right there, I wanted you guys to see. Oh, I went back to the wrong document. So that video right there was showing you how convergent boundary, one type of convergent boundary, forming in New Zealand and volcanic activity occurring. So that would be this one right here. I'm hoping these videos work. So I'm going to go back to the next YouTube video. The next YouTube video is going to cover divergent and convergent boundaries. So let's go back to that and let's see what happens.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart. And it's this that ultimately causes the continents to move. Where the plates collide, the rock on the seafloor containing carbon from the dead plankton is carried deep into the Earth. As it descends, this layer of rock is heated, so the rock melts, releasing carbon dioxide. And gas is returned back into the atmosphere during an eruption. The remarkable cycle is complete.
All right.
We are KiwiCo, and we deliver hands-on STEM
video.
projects designed to inspire young innovators.
Let's pause this. Pause. All right. So there was the information on divergent and convergent boundaries. So hopefully those couple videos helped you guys out. So our next type of tectonics, if you want to say, is our hotspots. And when we are talking about Hawaii, we're talking about hotspots. Oh, hotspots. And for hotspots, I want to create a picture here for you. It's in here. So hotspots are different from convergent and divergent in that not at the edge of the plates that this activity is taking place. It's in the middle of the plates. So let's go back up. Let's bring our hotspots down here. Yeah. So in your notes, I want you to draw this picture. All right. So we have plate motion here, volcano number 1, moving over magma. All right. What happens with a hotspot? The hotspot always stays where it is. The hotspot doesn't move. It's the plate that is moving above the hotspot. So like in Hawaii, the islands are moving, okay? So when the first Hawaiian island was made, it was all by itself. It was over that hotspot. So that island formed, magma came up, kept adding layers onto it, and over time, millions and millions of years, the plate has moved. So that island has moved and is no longer over the hotspot, as you can see in picture number 2. So it's right here. So once it lost its source of energy, which was the magma coming up from that hotspot, that island has gradually gotten smaller. Okay, and island number 2 would now be over the hotspot, and island number 2 would be forming and be larger than island number 1. And if I had more room here, we could keep this going. Island number 1 be further down, smaller. Island number 2 would lose its source and be smaller. Then island number 3 would be over the hotspot. So with hotspots, the hotspot doesn't move. It's the plate moving over the hotspot. All right. So there's a weak part of the plate where the hotspot melts through because there's so much magma there at that spot to get through the plates. All right. So what you have to remember with hotspots. The hotspot doesn't move. It's the plate moving over the hotspot. And this is how the Hawaiian Islands were formed. So let me put that up here. This is how the Hawaiian islands were formed. Okay. So get that picture down in your notes. Again, pause it here. If you didn't pause, I'm going to go show you a quick YouTube video, and I'm hoping these YouTube videos are working on this. I'll find out as soon as I'm done with this. I'm doing this early in the morning, so hopefully it all works. So this is a YouTube video on how a hotspot created the Hawaiian Islands. So let's go to it, and let's play it.
Volcanoes usually occur at plate boundaries, where the continents collide. When they hit, they release unimaginable energy, punching up molten rock from deep inside the Earth. The Pacific Ring of Fire marks a whole series of these plate edges. It's got half the world's active volcanoes. Hawaii is more than 2,000 miles from the nearest collision zone. Beneath the ocean floor is a mysterious area of super hot liquid rock. Hot enough to melt a hole through the Pacific plate, punching up fresh lava. It's called a hot spot. The ocean floor is creeping gradually northwest at 3 inches a year, but the hot spot under it doesn't move. A volcanic island builds up, but as it moves away from the hot spot, it is cut off from the source of lava and dies. Over the hot spot, a new volcano forms. But if the big island is growing, then what's happening to the island of Oahu? Oahu should be shield-shaped, circular, but it's not. It's long and thin. There's a chunk of it missing. All that's left are 1,000-foot-high cliffs.
Because you can actually tell that this isn't a shield volcano anymore, that there's something definitely missing from the spot.
As the water turns the rock to soil, the cracks burrow even deeper. A fatal weak spot develops, until one day, it all just lets go. This cliff is a crack, 1,000 feet deep. Based on the shape of Oahu and the height of the cliffs, Lloyd estimates the land used to extend out from here for another 20 miles.
All this used to be solid rock. And all that rock disappeared to the ocean below.
Two million years ago, the island fell apart. 300 square miles, 20 trillion tons of rock dumped in the Pacific Ocean. That's why Oahu has an unusual shape. The rock slide really has taken a bite out of the island.
All right, so hopefully that video helped you understand a little bit more about hotspots. Again, these are your notes for this section. If you have any questions, please ask me as you are going through these notes. And I see here I misspelled Hawaiian. Let's fix that right there. Also, a term that I'm going to put here at the end, and the term is called convection. So we showed you guys the demonstration yesterday with convection. So remember, convection is when warm matter, we'll say matter, rises and cooler matter, and the matter could be anything, could be air, water, anything, goes through convection, matter sinks. This is how the plates move. All right, this is how plates tectonics. Just add that to the end of your notes, okay? So when warm matter rises and cooler matter sinks, this is how plate tectonics happens. Okay, so these are in the notes. Again, pause where you have to in those and go back to see the images. Already at 19 minutes and 45 seconds, so I'm going to cut this right now because it's going to take a long time to upload to YouTube. So These were your notes on plate tectonics. Hope you enjoyed. Thanks for watching the video. Later.